Hello world, my name is Victor Engelmann, and in this video series I want to show you around in the Linux kernel. I want to really dive into the subject. I want to go through the source code and show you everything and explain what it's doing. And yeah, let's just dive right in. So when you want to start kernel development, then of course you need the source code of the kernel. That's not surprising. So I go to kernel.org and I go to browse for one of these kernels. Kernel.org has been the main website of the Linux kernel since forever. So I copy this link up here. And now I'm going to use a program called Git. I guess you know that program already. It's a very popular version control system. If you don't have it on Manjaro, I'm using Manjaro here. On Manjaro I would install it with sudo pacman-s git. I have already installed it, but okay. Yeah, on other distributions the command might be different, like sudo apt install git, or maybe urpmi. It depends on your distribution. I guess you know how to install software on your machine if you are ambitious enough to start kernel development. Okay, so as I said, I've copied this link up here. And now I make a directory. And now I will use that version control system Git to clone this Git repository. So I will make a local copy of it. This repository is over 2 gigabytes large, so it's going to take a while. Okay, so now we have the source code, and well, if you want to become a kernel developer, then you probably are interested in how to edit the source code. You know, I personally like the text editor Kate for programming because of its multi-document support, but yeah, for something this big, I think we need something more sophisticated, you know, a real full-fledged integrated development environment, an IDE. And yeah, on Linux I like to use KDevelop for that. So this is how KDevelop looks when you start it. And then you go to project, import project. Then you navigate to the directory where you've downloaded the Linux source code, select the make file, continue, finish. Now it takes a while. You see the progress down here. Okay. And now you see, yeah, this is a file hierarchy. You have the different subdirectories here. And yeah, for this video I want to show you the file main.c that's in the init subdirectory. Okay, yeah, when you import the project like this, then you get a lot of error messages here because it's looking for header files. And it doesn't know where to look for these headers. So you go to the settings, language support. The first tab here is for the include directories. And then you click here. And then you click here on this selection button, select the directory. And then you select this include directory inside the Linux source code directory. Then don't forget to press this little plus so that it is actually added to this list. Okay. Now it takes a while. You see it's at 3%. You see it's at 3% importing that stuff, but okay. What I wanted to show you in this file is down here around line 800 at the moment. Here we have the function start kernel, and yeah, this is the starting point of the kernel. So when the kernel is booted, this is where it starts running. Okay, so yeah, if you want to start looking into the source code, I think this is a good starting point. Okay, so now let's say you have downloaded the source code, maybe you've edited it, maybe you've only looked at it, and yeah, the next thing you want to do, of course, is you want to compile it and then run it. So how do you compile the source code? So you go back to kernel.org and go to documentation down here, and you need to scroll down a bit. Here's a section, Introduction to Kernel Development, and in there you have minimal requirements to compile the kernel. Okay, and there you have this list of programs that you need to have. So on a Manjaro system, I would again say sudo pacman-s and then list these packages that I want to install. Again, on different distributions, the command may be different, like apt install or urpmi or whatever. So I would install gcc. Clang llvm is optional. Make bin utils flex bison util-linux. If you are going through the Linux from scratch book or the videos that I'm putting up about Linux from scratch, some of these packages might look familiar to you. Okay, util-linux, kmod, e2fs prox for ext2 file systems, jfs utils, riser fs prox, xfs prox, squash fs tools, btrfs prox, pcmcia utils, quota tools, ppp, nfs utils, proc ps, o profile, udev, grub, mce log, IP tables, open SSL, lib crypto, PC calculator, and yeah, things is only needed for the kernel documentation, so I'm gonna skip that. Okay, it tells me that I basically have all those things installed, except a few things. Well, PCMCIA utils, I don't know who still has PCMCIA. That's pretty old technology, and I was able to build the kernel without that, so I'm gonna ignore that. The same thing for PPP, oprofile, mcelog, and libcrypto. I've managed to build without these. But from an older version of this list of things that we need, I have also installed the packages pahole, cpio, xmlto, and then Python Sphinx and Python Sphinx _rtd _theme. I think it's a good thing to also have Perl, tar, and xz and xz. Yeah. Oh, I mistyped Perl. Well, I have all these already installed, so I'm just gonna say no here. Okay, so now I have all the programs that I need to compile the source. And yeah, so that brings us to the topic of the .config file. So when you compile the Linux kernel, the .config file is a super central thing. So the Linux kernel has over 11,000 different options, and yeah, the config file stores all of your selections for these options. And yeah, let's go into the Linux directory. So you see there is no .config file yet, because, well, the Linux kernel doesn't tell you which options you should take. So yeah, there is no .config file at this point. And but without a config file, you cannot build the kernel. So yeah, so you need a .config file. And how do you get one? Now, one way you could get a config file is by saying make config. But that would basically just give you a command line tool that asks you about each and every of the 11,000 options, and you would have to manually select one, and you would have to manually set each and every of these 11,000 options, and I think that's not a good idea. So I think make config, yeah, you shouldn't do that. You can say make def config. That would give you the default config, where every of these variables gets their default value, so something that the developer of each of these options thought would make sense. but well, the developer of a feature doesn't necessarily know your hardware or your distribution and the selection of drivers and programs of your distribution. So default configs might not be the best way to go here. I think the best option is to take the config file from your distribution, because your distribution knows, to at least to some extent, the programs that are available to you. It knows at least to some extent which drivers are available to you. So I think it's really the best idea to take the config file from your distribution, and there is actually a quite easy way to get that, because when you build the kernel, the compilation really puts the entire .config file into the kernel as a string resource, and you can just ask the kernel, hey, give me the config file. You can do that by saying zcat proc config. So that's the configuration of Manjaro. So that's Manjaro's configuration. And I could just save that as .config, or if you don't have zcat, you can just copy and this is gzipped, so you have to unzip it. Now it's named just config, which is not the correct name, so I'll rename config to .config. Okay, now when you already have a config, then you can edit the config with make menu config. And this gives you this text-based tool to edit all your options. Like here you can select if you want it to be 64-bit or 32-bit, power management stuff. I won't touch that. Don't want to save it, no. You can also do make xconfig, which will give you another configuration tool, but it's not text-based. It's it's a graphical tool, but it's very similar. So I think menu config is the way most people go. Okay. You see, you have again such a tree of options. Here you would have again the option to make it a 32 or 64-bit kernel. This card changes, but I want to point out one thing. I have downloaded the kernel source, as you can see up here, for 512 RC7. Okay, and my config file is of course for the currently running kernel, which kernel is currently running. Where with uname-a, I can see the kernel that's currently running is named 5.11.10-1-Manjaro. So this is a config file for 5.11, but I'm about to compile 5.12, and some options might have been added since 5.11, and for these options, this config file doesn't have any entries. So if I tried to build the kernel with this config file, I would probably get errors. And I've actually tried it, I would get errors. So what you would want to do is update this old config file to the new kernel version. And you can do that with make old config. If you do make old config, it's similar to make config in that it will ask you about certain options, but it will only ask you about the new options that have been added since the release of the kernel that this config file was for. So my 5.11 had no support for ACPI firmware performance data table. That has been added between 5.11 and 5.12, and now I can just hit return, and that will select the default value for this option, the same that you would get in make dev config. And I can do that for all the new options. Enter return, 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 return. You can hold down the return key if you want. Okay, and now my .config file is updated for 5.12. So now I would be able to compile using the command make, but well, I have one problem. It depends what you want to do. I want to keep this video relatively simple, so I don't want to go into the initial RAM drive magic stuff. So with the Manjaro config, I have a problem. So I need to go to the option config underscore ext4 underscore fs, hit return. And you see here I have the option M. M means that the support for the ext4 file system is going to be built as a kernel module. Now the thing about that is, if I try to boot this kernel, I cannot load a kernel module from a hard drive that has a file system that I don't have support for, you know. So the module would be on an ext4 file system, so I would need ext4 support to load the kernel module from an ext4 drive. So Manjaro would solve that by putting the kernel module for ext4 into the initial RAM drive, but as I said, I want to avoid going into initial RAM drive stuff, so I will change this M to a Y, and then the support for the ext4 file system is going to be built into the kernel itself and not as a module that needs to be loaded at runtime from an ext4 formatted drive. Okay, now we have everything prepared. We can just start make to compile the kernel, or I will say make J8, because with nproc you can see I have 8 processor cores, and that means that I can run 8 processes in parallel. So if I say make -J8, 8 source files will be compiled in parallel, and that will just speed up things. Okay, start this. Yeah, this will take quite a while, but yeah, while it's running, I want to mention this book here by Greg Crower-Hartman, one of the main maintainers of the kernel. Linux kernel in a nutshell. It was about programming the Linux kernel, but it's not. This book is about configuring it and building it and booting it, but not about programming. And it's a pretty old book. So it's from, I think, 2007. And 2007 is quite some time ago. I'm recording this video in 2021, so this book is 14 years old. And it talks about Linux version 2.6, which, that was a legendary kernel. It's been the main kernel for, I think, 7.5 years. So when I switched to Linux in 2005, it was a pretty new kernel, but it's been the main kernel for the longest time, and it was the first kernel that supported several things that are standard these days, like the dev directory. So again, it's an old book, but I'm happy to have it, because it gives you some insight into how the kernel developers think, and it also has some really good references about the different command line parameters that you can pass to the kernel through your grub configuration. It has several hints about how to set your options. It's a really useful book, I think, so I'm really happy to have it. So yeah. Okay, so I'm gonna let this run for a while now. Last time I ran it, it took about 2.5 hours, so yeah. Okay, compiling has finished. That was a bit quicker than I expected. I hope that's not a bad sign. Okay, I want to mention a few things. If your compilation fails, or one of the next steps, then you are probably just missing some package. And then I would advise you to just Google for your distribution name and something like compile kernel or something. And then you will usually find some information about compiling kernels on your distribution, if they have anything that's not completely standard. And if you have any problems, do not try to just say make again, because your whole tree is in a broken state at that point. So you should first have make Mr. Proper, and that just resets your entire tree back to the initial state. But make Mr. Proper also deletes your config file, so you should back up your config file before you do a make Mr. Proper. Okay, so the next thing that we need to do is make modules install. And this writes to system locations, so we will need sudo make modules install. Okay, so we've installed the modules. One thing I want to point out, you can see here 5120 RC7, that dash Manjaro. That's the name of the kernel. That's how the kernel says, this is my name. Let's say you want to make your own Linux distribution, then you might not want to have some other distribution's name as the identifier of your kernel. Then you could go to the config file and go to the variable local version. Where is it? Config local version. Yeah, this is where that identifier is controlled. So that's what you would have to change if you want to make your own distribution. You might also want to change the default host name. Okay, good. So we've installed the modules. If you're interested, they are now in lib modules, and then the kernel version. So that's where they are now. Then we do a sudo make install. Okay, this has now copied the file to the boot directory. So this is now here, this VM Linux file. Yeah, the other kernels here have more expressive names, so I think it's a good idea to change that name also. And you can actually do this automatically. You can use the command make with the special target kernel version inside your source directory, of course. And that will then print out the version number for that kernel. So then we can use that here. And for this processor suffix, we can take uname-m. So $uname-m. Good. So next thing we need to do. So the kernel is now in /boot, but to really boot the kernel, we need to inform the bootloader about it. I mean, the file is there, but the bootloader would not list it yet. So we have this grubcfg, and this is what grub uses to make its list of choices when you reboot. We could edit that configuration directly, but yeah, next time you install some updates on your machine, also maybe a new kernel, then the operating system might just say, oh, I will do an update grub now. And if you have this update grub will just overwrite your grubcfg. So if you have written your entry directly into boot grubcfg, yeah, then it will just be gone and you will not be able to boot your kernel anymore. So a way to do this in a stable way that will survive an update grub, you can edit etc grubd 40 custom. So in grubd you have several scripts which are always run by update grub. So they are used to generate the new grubcfg. So this script in particular will just print everything after the first few lines. So everything that you put down here will be put into the new grubcfg. So what would we put here? I mean, we've taken the config from the distribution, so I think it just makes sense to also look at the grubcfg from the distribution. Okay, and up here we have several entries for Manjaro Linux. I will just copy one of them and paste it here. Okay, so let's say I'm making my own distribution now. Algorithm in Linux with kernel 5.12 RC7. Get rid of all this stuff. Okay. Okay, so these options up here are not really necessary. So I will just comment them out. And I will also comment out this init.rd here. But let me emphasize one more time. I would not be able to turn off the initial RAM drive here if I had not built the support for ext4 file systems into the kernel. So if you don't have an initial RAM drive, then the file system type of your root drive must be built into the kernel. Otherwise the kernel will want to take the support for that file system type from the initial RAM drive, and that will just not work, and then you will get a kernel panic, and yeah, that's not gonna work. Okay, so then we only have these two lines here left. I'll remove the quiet, and yeah, to avoid any problems with hibernation, I've also removed that part. Okay. Okay, what does this all mean? This search tells grub, so this is an information for grub itself. This search tells grub that the hard drive with this UUID is our root hard drive. So this is where grub will then look into the directory boot and for the file vmlinux 5.12.0 RC7. You might also see something like set root equals hd0 and then partition of an MS-DOS partition, but okay. So This here is more robust if you change, if you unplug your hard drive and plug it into some other port on your main board, then this set root equals hd0 ms-DOS 5 or whatever would not work anymore, because well, hd0 might not be the correct identification anymore, but the search will still work, because this really looks at the unique identifiers of the hard drives and selects the correct hard drive by this. You might also see something here for the root, UUID equals, and then also that, or maybe a different UUID here, but I've had problems in the past with a UUID here. So def nvme0 n1p5, that's, if I look into etc mtab, up here my root drive is def nvme0 n1 partition 5. Okay, and yeah, as I told you, it's formatted ext4, so that's how you know what file system you need. Okay. This here means read-write, so that you can write to the hard drive afterwards. If you have a dedicated boot partition, then you might not have to look in the subdirectory boot, because if that is mounted, if that drive is just mounted at /boot, then the kernel would be in the root directory of that partition, right? So so this location here is relative to that drive. Okay. And if you have a dedicated drive for that, then on that drive you wouldn't have the subdirectory, then this would be the root directory of that drive. Okay, now before I boot this, I will put a little error here. So I want this file name to be wrong, so that I can show you a little bit around in grub. So I'll save this, then sudo update grub. Okay. Unknown device type NVMe0 and 1, that's always unnerving to me, but it still works. Okay, so I will now reboot. I'm sorry, but I have to re-record this reboot. So because the autofocus of my camera just completely ruined the recording, and that's why I have put this yellow little piece of paper here. That's to help my camera's autofocus. So, okay. Let's reboot again. Okay, so this is grub. I guess you've seen that already before. And down here I have my algorithm Linux. But as I told you, I've mistyped the file name, so if I try to run it, it will just say file not found. Not surprisingly, if the file name is wrong. So if this was my only kernel and this was my only grubcfg, then I would have broken my computer at this point, right? Because this entry doesn't work. And if that's my only entry, then I cannot get into the operating system to fix the problem, right? But that's not true, because down here you see you can press E to edit the boot options or C to go to a grub command line. So if I press E, then I can simply edit the grubcfg entry that I had made before, and I can just fix the file name here. And then I could press F10 and then it would boot. But I will press escape instead, because I also want to go into the grub command line with a C. And yeah, here you can even boot kernels without even a working grubcfg. You can just use the same commands from the grubcfg that you've seen in the grubcfg, like insert module gzio, for example, is one module that you could load. Or you could set the root to, this is an American keyboard layout and I have a German keyboard, so it's a bit, I set root to HD, and I even have tab completion. So it now tells me HD0 or HD1. Well, let's try HD0, comma, tab completion. Okay, well, partition 1, 2, 3, and 4. Yeah, this is not the UUID that we've seen before, and I'm pretty sure that my boot disk was not partition 4, so HD0 was wrong apparently, so let's try HD1. Okay, what do we have here? NTFS, ext, that looks good. Partition 5, we had partition 5 before, so that sounds good. So let's say GPT-5 here. Okay, and now let's, is this still on? Can you still see that? In the line down there, I'll just press escape and command line again. So set root equals HD1, comma GPT-5. Okay. And now I can say Linux /boot /VM Linux minus 5.12.0 -RC7, and I can again use tab completion, so that's nice. I need to tell my Linux kernel which root drive to use. That was dev nv me 0 n1 p5, and we want to mount that with read write. Okay, that looks good. And now I can just say boot. And we're booting our system. So there we are back in the graphical environment. Okay, so we have successfully booted our self-compiled kernel. With uname -a, we can check, okay, 5120 RC7, so nothing is faked here. On my other machine, where I have an NVIDIA graphics card, I have had problems with self-compiled kernels because, well, NVIDIA doesn't necessarily play well with self-compiled kernels. Normally, when you have a new kernel, you would recompile some of the kernel modules with DKMS, but yeah, NVIDIA doesn't integrate into that very well. And Manjaro has its own way of dealing with NVIDIA graphics cards, so I was also too afraid to mess with that to install the official NVIDIA driver. So yeah, but I was still able, I mean, I tried to boot the kernel, but the screen stayed black. And but with Control-Alt-F2, I was able to go into a text mode login and log in there. And yeah, that really just proved that the problem wasn't the kernel itself. It was a driver problem, you know. So so if you have any problems, just keep in mind it might not be the kernel itself that's the problem. Okay, I think this is a good point to finish this video. If you liked this video, like it, share it, subscribe. And please consider turning off your ad blocker while watching these videos. That would help me a lot. Next time I want to go into kernel modules and drivers. I think that's going to be interesting, so definitely don't miss that. So see you next time, and goodbye world.